All right, so if you're interested, the app that I'm going to walk through today is up on the DerbyPy GitHub website. You can just go to GitHub or Google GitHub DerbyPy and find it. If you can happen to read that URL up there, great. Briefly today, what we're going to cover is if you're trying to connect. So Flask is for those who don't know, Flask is a web framework that's popular in certain areas of the Python ecosystem. Its complement would be something like Django. Django is a batteries included version. Are we good, Royce? You good? Django is a batteries included version. They have a very large ecosystem, a lot of apps, and Django itself does a lot for you. Flask is trying to be on the other side of the continuum, to be relatively small, not do a whole lot for you other than the basics, and let the community put out apps and plugins as needed. So in Django, you have just the very nature of Django is such that you almost always have a database with it. I suppose you could not have it, but if you're not going to use a database, Django is probably really overkill because a lot of the extra batteries included stuff is going to depend on that database. Flask, on the other hand, is designed to not have any database associated with it, standalone. All it's taking care of is some web semantics, some things about how you initialize the app and put your views together, templating. In recent versions, they added some CLI support, so it's easier to get CLI commands into it. And the database stuff that you want to do is going to be extra. There's a lot of different ORMs, object relational mappers, which are libraries that make it easier to interact with SQL databases using the kind of translating the tables into objects. And one of the ones that I like the best is called SQAlchemy. And we've been using SQAlchemy, gosh, I think as long as I've been doing Python. So it's been 12 years. It certainly wasn't what it is today. The guy that authors it has probably got to be one of the smartest developers I've ever interacted with. He uses an incredible number of programming paradigms to make SQAlchemy very dynamic, and so you can start at a really high level with entities, and I'll show you what those look like. But you can also, a lot of ORMs, they start getting in the way when you want to do more than the basics. SQAlchemy is the first one I've ever used that really lets you go all the way down, continuing to use kind of functions and helpers to where you could actually write SQL in Python, which you might wonder why you do that. The reason that it's really helpful is because you can then begin to compose SQL parts. So, for example, you might have on a bunch of different tables, you might need to join in certain tables and then put where clauses on it for security. Well, you could write all of that into a function, and you could write your basic SQL statements, pass that into a function, and then those SQL statements would come back with that functionality added. So SQAlchemy has a lot to offer. It is complex. I think when I started, it took me, I would say, about 12 months before I figured out exactly what I was doing. I think that would have. I'm a person who has a tendency to jump in and just try to learn stuff. If I had taken the time to just watch a couple of videos and read through the documentation, I think it probably would have cut my learning time down by maybe about 9 of those 10 months. But I was trying to go off of what I knew, and there's two different paradigms in SQAlchemy. One is the declarative approach, and then one is the SQL core, and you really have to understand the difference between those things, or you'll be confused by the Stack Overflow post, because you'll be looking for one side of it and you'll get the other and you won't know how to translate them, and it'll just be really, really frustrating. So SQAlchemy, very powerful library. Strongly encourage you to use it. If you do a lot of database work, it's worth learning, but I would encourage you to watch some videos and read through the docs pretty well before you just jump in. So in the Flask world, we get very creative in our library names. And so we have Flask SQAlchemy, which is a library that takes Flask and SQAlchemy and gives you some tooling to use those things together. You would assume that ends up being pretty simple, and in some ways it is. But when you want to get anything like a more complicated app, you want to start adding testing, how to do all that stuff and how to put it together in the right order can really be a frustrating thing. And so that's really going to be what we're looking at this evening, is we're going to look at how these things go together. We're going to talk a little bit about Flask's app context, which is really important to understand what's going on behind the scenes. Flask uses global objects for a lot of getting a hold of things like the database or the app. And those global objects are really just proxy objects. They're fronts to stuff that's really sitting behind it. And that only works if you've properly prepared those globals by setting up the apps and pushing context. And that all happens in a Flask context. That all happens automatically for you upon a request coming into the web app. But when you start testing and wanting to do things like testing your database objects, there's no request. And so this is where, you start, if you were just kind of putting things together on your own, everything's going through your views, everything's working, and then all of a sudden you realize, I want to write this function and I don't really need a view because I'm starting to separate my code, and so this thing just needs the database, and so you try to write it and everything blows up and you can't understand why. So we're going to try to just walk through some of those things, specifically in a testing context, also using PyTest for our test runner, because PyTest is the best test runner there is in Python, and it gives you some really cool functionality. One of those things is fixtures, and you'll see how we use those here to solve I need a whole bunch of stuff initialized to run my test problem here in just a little bit. So that's longer than I anticipated introduction. Any questions about any of these libraries or what we're going to be doing or anything else related? Okay, so everybody tests their code, right? And I don't mean manually, like automated tests. Automated tests are cool. There's a lot of things in the development ecosystem that if you listen to, podcasts, you maybe watch videos on YouTube, I don't know, you read Hacker News, there's so much hype about everything. It's very difficult to understand what actually makes a difference in the life of a developer, especially if you're doing it professionally. If I had to get rid of kind of all of my stuff that in my development environment, and can only kind of keep one major thing, it would be Python. But if I could keep two major things, it would be Python and automated tests. I honestly don't know that I could program these days without having the flexibility to write tests. Once you learn how to do it, it becomes a way of writing code, and it makes your code better. So learn how to write automated tests, learn that tooling. In addition to that, learn how to use continuous integration. That'll be another thing. When you can commit something to GitHub and you can kick off your automated tests, it means that when you're coding, you can just run the tests that are close to the stuff that you're changing, and then let the CI catch everything else, which might include different platforms, different operating systems, and all that stuff. So learning how to put all that stuff together initially does take time. It can be frustrating, but once you get the pieces working, it's an investment that will pay dividends. Like, sometimes you do stuff in tech and you're just like, I wish I wouldn't have wasted my time on that. I promise you, if you learn how to do automated testing and you learn how to do continuous integration, you will thank me, or you'll forget about me and not thank me, but you'll be glad that you did it. Do what? Just remember the CI software too. Yep. Okay. So this app, as I said, is up on GitHub. You're welcome to pull it down, run it, walk through it if you want to. We're going to do a walkthrough and see how that goes. So I actually already activated this virtual environment, I think. Yeah. So I'm not going to run through setting this up. I've run the steps. I have the steps in the README. It's not complicated as long as you know how to run pip. And those 3 steps there should get the application running with all of your tests, assuming that you've got your database up So brief intro to that. I have a Docker Compose file here, which will spin up a version of Postgres on Alpine, which is a really small Linux distribution that's used for a lot of containers, and keeps your machine from filling up with all these big Ubuntu Debian images. You're welcome to use your own server. If you use your own server, you'll have to come in here to the app, and you'll have to change this connection string, probably, depending upon what port you have stuff running on and maybe the database and stuff. But just know that you're going to need, I'm doing this with Postgres. You can do it with MySQL. There's no reason, there's nothing in this app that's specific to PostgreSQL. I just think it's a great database, and that's what we use at work most of the time. So dependencies, all the dependencies in this app are in requirements.txt. I suppose it's possible that something I'm doing here might break. If you try to run this 6 months from now, I highly doubt it because I'm not doing a whole lot that's really custom or special. I would imagine this continues to work for years just off of this. But one of the things that you might want to think about doing with dependencies is freezing them. We use a tool at work called pip tools, I think, to use for turning a file like this into one that has all of these dependencies as well as all of its dependencies. So your whole dependency tree, it'll freeze everything to specific versions. You can commit that with your code and keep track of what versions you're testing against. It's really helpful. I'd recommend using that if you're running Python in production and you need to know what version of your dependencies are. There's another tool called pipenv that's out there. I actually was a big fan of pipenv about 18 months ago. I don't think they've made a release in almost a year now, and I think the project as a whole, when we started moving away from it, I think the project as a whole was trying to do too much, and I don't think it was architected properly. So it was a great idea. I don't know that they'll be able to kind of get out of the hole that they're in. So I'd actually encourage you, if you're using it, to begin to learn to move away from that unless they start making really big strides in cleaning up that project. We've actually found it to be buggy in some significant ways, in ways that we were using it. So it's really handy. It looks cool, but if you're using it in production, you may end up having problems you don't realize you have. So those are the requirements for this application. Yeah. Pipenv. Pipenv is what you should stay away from or migrate away from. That's my recommendation. Use pip tools instead. Not as fancy, but does the basics and is reliable. Okay, so if you go to the Flask, if you go look at the Flask Quick Start, this looks like a really simple app, and it is. I mean, you could put this in a Python file, and you could run Python on it, and it would run, and it would serve up an application for you that returns hello world. One of the things that's good about Flask is one of the things that also makes things complicated, because if you start with this pattern and then you try to do advanced things, you're going to run into a problem. And the problem is, that creating your app like this, needing to have your app instantiated to do things like define your views, as you begin to add more files and you begin to add more initialization that's necessary in your app, you start to get kind of circular dependencies. Some files need things from the app, but the app needs things from the views, and all of a sudden you got two things kind of trying to import each other, and it kind of turns into a problem. So when you start to build more advanced apps, there is a pattern called the application factory pattern, where you can create your app as a function. It allows you to so the app doesn't start immediately when that file is executed, which has a lot of advantages I'm not going to go into right now, but also creates some complications, because now you're like, well, how do I get a hold of my app and how do I restructure things? So that's what we're going to go into in a little bit. So the README in this project has links, as you saw, to some of these things. You can go ahead and go out to the link and read a little bit more about it. It's worth reading through these things. My goal here is not to explain all of it, but to simply tell you what it's called and let you know a little bit of why we're doing it this way, so that you can you can do it yourself if you want to. So app factory pattern. The second thing that you'll see in this file down here, is I've got this CLI function that's just kind of hanging out on its own. It doesn't even do anything, it doesn't look like. But the key here is that the class here is the Flask group, and that we're feeding it our create app initialization function. And so Flask, normally when you run a Flask app, they want you to use the Flask binary that comes with the Flask library. And so that's how you're going to run your app. I personally don't really like that. If I'm going to build an app, I kind of want to give my app a name, and I want to call it my app name. I don't want to do Flask stuff. I want to do Flog stuff, Flog being the name of my app. So this is another thing that I'm not going to explain a whole lot. I'm just going to let you know that custom scripts are something that Flask supports, so that you can have your own CLI application for your app. From your app coding perspective, you really only need two things. You need this one line, and that's really it. It's pretty simple, as long as you know that that's what you need. And then the second thing that you're going to need is in your setup.py file, you're going to need to tell kind of the Python setup tools environment that this app actually has a console script, and you're going to have to tell it the name of it, and you're going to have to tell it where that entry callable is. And so this is how you do that. This snippet is directly from the Flask doc, so you can get that as well. And so once you install this app into your virtual environment, that Flog binary ends up becoming available, in your path. Okay, so any questions so far? Okay, so what's actually happening here? I called Flog earlier. So Python is actually, the Python setup tools installer has created a binary. That binary knows how to load the Python from the virtual environment that it was installed into, and then it basically is going to open my app file. It's going to import this callable, and it's going to run it. Well, that callable is decorated by the Flask group, and so it gets all kinds of functionality built into it. And so that's what gives me this really nice, output here, command arguments. This actually is coming from a library called Click. Click is the machinery that's handling the CLI application. Flask and Click are built by the same guy and are now maintained by the same group, the Palettes group. And so it made a lot of sense to get Flask some of the Click goodness. It really is a nice library for building CLI applications. You can add more commands. So right now, the only commands we see here are the 3 that are provided by Flask. You can easily add your own commands, which we do constantly at work in our production apps. We add commands that make it easy to do certain things in the application, and then we call those commands frequently from either cron jobs or like systemd timers, where we want an entry point for the application, or it's you need to log in, you need to do some debugging or something, and I've got tools at my disposal to do that. So a common pattern for us is to write core application logic in libraries that are agnostic about whether they're running in a view context, in a web context, or in a CLI context, or in a salary worker. And so probably 95% of the logic is built in those core libraries, which are really easy to test. And then each entry point, whether it's CLI or a web request, then kind of ties into that library and uses it. So that's a nice pattern that we've used to build our apps in such a way that, like, if I build a CLI command and I really want a lot of that functionality for a web view too, it's just a nice way to not end up duplicating code to build it that way. So CLI application, custom script. Okay, fixtures. So here's the fun. Let me demonstrate the fun of this. So normally you would expect to be able to do something like so let's get a shell here in my virtual environment, and I'm going to import flog.app. No, I'm going to do from flog.app, import DB. Okay, so DB has been defined. DB is defined in my app as the SQAlchemy instance. And so again, I'm not going to go into a lot of detail about what this SQAlchemy instance is. Just know that it's the main class that Flask SQAlchemy is using to kind of link Flask and SQAlchemy together. So it's going to do, ideally, it's going to do a lot of that setup to make the two libraries easily work together. When we go look at our entities, you also see that we inherit, our entities inherit from an attribute on this DB object. So it needs to be able to import from here. I'll show that in just a second. But one of the things that SQAlchemy gives us is the ability to automatically generate in our database all of the tables that you would have for your entities. So I guess maybe I'll just show you the entities here. So I've got a post entity. So I'm modeling a blog here. We got Flog, we got Flask, and then blog. So that's why the app's called Flog. But it's we've got a post, and then we've got comments which are related to posts. So very typical kind of hello world example. Okay, so these even though these are classes, because of the machinery that SQAlchemy and Flask SQAlchemy are giving us, these things are actually being turned into, or can be turned into, tables in the database. And SQAlchemy will allow us to run queries against the database pretty easily. We'll look at what that looks like in a second. But the main thing I want to demonstrate here is that, and again, this has this has a lot to do with kind of how Python works, because it works at runtime. When this runs, notice that my app is not created yet. Well, we have to associate the app with the SQAlchemy. Like SQAlchemy, Flask SQAlchemy has to know what app is it that you're trying to integrate with. And so we have kind of a chicken and an egg problem here, where I have to define the DB first. It has to be in the global scope, because when I create my entities, I have to be able to import it. So I can't kind of have that DB inside the function. I can't define it inside the function. And so because this problem is so common, most Flask extensions will allow you to initialize kind of the module level object, but it's kind of empty on the inside, and then they give you an init app function on it, or method on it, that allows you to really initialize that thing for the app. And the key thing for this is that Flask is built and it's designed to allow you to run multiple Flask applications inside the same process. So another reason for this misdirection is the SQAlchemy class and library is not actually saving any state in this object itself. It's actually saving all of its state in the app instance. And so it's really just setting up that shell, and then anytime it needs to do something, the first thing it does is say, well, what app is active? And then it'll get its data from that app, and then it'll use it. Well, that feature is also what ends up causing us some difficulties and makes working with these objects pretty hairy. If you're used to just writing scripts and you kind of start at the top down and anything you define above is available and ready below, well then all you got to do is run Python and it's kind of all there for you. Or you can run Python and import that file and it's all there. But the setup semantics here are a little bit different, and that's what we're gonna show. I'm gonna show some of the issues with this. So the first thing I'm gonna do, so SQAlchemy provides, and Flask SQAlchemy provide a way, once your models are defined here, or I call them entities, but once my entities are defined, I should be able to tell Flask SQAlchemy, hey, go create all those things. Just go create the tables. I don't want to have to run the SQL myself. I don't have to write it. You already know what the table should look like. Just go build it. So I should be able to call db.createAll. Anybody know what's going to happen? It's not, actually. It's going to give me an error because even though the DB object is set up, it's still empty inside, and it doesn't know what app to use. In fact, in this process right now, I've not actually instantiated an app. So there's actually nothing, it doesn't know how to proceed because there's no active app. So this is the error that you get. There's no application found. And again, the reason for that is Flask works with globals, but those globals are just proxies to the applications that are active behind it. And we've got to kind of do something to fix that. So I'm going to actually fix it manually here just to see what we would have to do. So the first thing I have to do is, initiate or initialize the app. Oh, I didn't import it. So you'll remember I had a create app function in app.py right here. And this is doing everything I need to properly set up this app. So the first thing I want to do is just get an app instance. So now I have an app instance. And I can actually run that same command, and it's still going to fail on me. No application found. Well, why not? Well, even though I have an application, I haven't, the way that Flask works, it creates something called an app context, and that app context is actually a stack of apps that have been created in that process. But the apps have to push themselves onto the app context, because there's actually a lot of cases where you might want to create an app and not actually push it into the app context. So Flask also gives us I don't even know what that is. It's just it's an object. It's a local proxy object. That current app should point to whatever the current app is. You'll see now that it says it's unbound, which means it doesn't know. There's nothing there behind. Again, we're just kind of showing the same thing multiple ways. So I could actually get that command to run earlier by passing in the app. So I could get it to run like this. It's the command is designed to get the app. If you want to pass it in, it'll just take the instance. It doesn't have to get the global to find it. And you'll see that this is actually the method that we use when we start instantiating the app for our tests. But I want to show you what it looks like to get it to do it the other way. So if I do with app.appContext, and now I do Flask.currentApp. Oh, there we go. So now, once I've pushed that app context, now all of the globals are kind of populated, and tools like Flask SQL can know which app is current. So now I can run db.createAll. Oh, that's right. Thank you. Yeah, I came out of that context. So I can do create all. Fine. I should have actually opened up a new tab because now I've got to do all that startup. But okay, so Python app from flog.app import create app db app equals create app app dot app context db dot create all. There we go. Okay, so at this point, all of my tables in the PostgreSQL database have been, all two of them, they've been created. So this all worked. The Flask SQL Alchemy tooling, because we were inside that app context, it was able to find the stuff that it needed and go ahead and connect to the database. Okay, any questions about that? There's two important things to understand about this. There's two concepts to understand. One is the app context, and the other one is the request context. Those are actually two different things. You'd think the app context means it's around for as long as the instance of the app, like you get it once, but that's actually not true. An app context is created at the same time a request context is made, but you may create an app context without a request context. So if you're ever having to work with this stuff, just remember that there are two things They're two different contexts, and they can have different kind of lifetime scopes depending upon what you're doing in the moment. Inside of a request, a web request, you'll get both. They'll both start up at the front side of the request. The request will happen, and they'll both get torn down at the end. But if you're doing something like testing or you're doing something like CLI apps, then you've got to be a little bit more particular about the context that exists and what you're doing with them. Any questions? Okay. So with that in mind, we're going to move on to PyTest. So PyTest, when we start to run our tests, there's some things that we're going to want to do. The first thing that I want to do when I run my tests is I want to delete everything that's in the database. So when I first start up my tests, I may have changed the number of fields that are, or the type of fields that are in my database objects, which means I need new columns in my tables. So when I start a new set of tests, I just want everything that used to be there to go away, and I'm going to recreate everything. For small and medium-sized apps, that's probably your best bet. It's honestly probably your best bet for even really big apps, but you could get into performance issues there if you're tearing down 1,000 tables and trying to recreate them at the start of every test. But at that point, you've got a big enough system that you can figure out how to engineer around that. So for all intents and purposes, tearing down the database and standing it up fresh, the schema anyway is, I think, a great way to do it. I have experimented in the past with actually trying to delete the database. But at least for Postgres, you usually end up having problems related to permissions and all kinds of stuff that's just not worth it. So you really want to keep the database and just clear out the objects that are inside of it. So for me, it's just a matter of speed and complexity. From my perspective, I'd rather just clear out those tables and keep the instance up instead of tearing that whole instance down and setting it all up again. And I'm sure doing that, Docker is doing a lot more work than just clearing out what's usually tens of tables at the most. We've also experimented some with, or we've talked about experimenting with just creating one big transaction around everything. But from my perspective, you run into problems because some things you do in the database can't happen inside of a transaction. Sometimes you actually double commit, which means now the data is actually in your database, but it's not supposed to be. That feels like a really big hack that's going to work 70% of the time, and the other 30% of the time you're going to be beating your head against the wall wishing you didn't do it that way. So I'll get into a little bit about what I do instead. We've talked now about cleaning up the schema, starting the schema over at the beginning of the test. We'll talk about what it looks like to clean up data here in just a second. Yeah, I think so. I've had to kind of fight a bit to keep it that way though, for some reason. Okay, so we use PyTest as our test runner, and PyTest has the concept of fixtures. In PyTest, fixtures are a way to. I better just show you one here because it's hard to explain. So if you look at the stuff that I'm testing my model in, notice here I ask for a parameter to this function called mixer. This is in PyTest. This is one type of fixture. So if you run a test method in PyTest, it is going to, and it doesn't, because PyTest is the one calling these functions, nothing else should be calling these methods. It's going to look at this and say, oh, you want that parameter must be a fixture. And a fixture is just a callable that you've defined as a fixture somewhere else that PyTest has been activated. So the configuration file that PyTest uses is called conftest. So I usually put a lot of my global fixtures in conftest. You don't have to put them there. You can put them anywhere that the file would be guaranteed to be imported during testing. If you have some fixtures that would only apply to maybe a group of modules or to a module itself, you can also put those fixtures in the test files that they belong in. They don't necessarily have to be global. The key is just that this code actually runs, and when it runs, this decorator is going to cause PyTest to recognize that's a fixture, create a reference to it kind of internally, and then when tests are called, it'll go back to that reference to see if a fixture exists. So let me just run my tests here, make sure they're all running, and then I'm going to go change this to mixers. Yeah, so mixture is not found. So it looked for a fixtures mixture, or fixture. Wow, that was a bad, tongue-tied. But you get the idea, right? So again, PyTest is trying to fill it. It can't fill it. PyTest offers a lot of helpful fixtures by default. There's one I use a lot called Tempter, which gives you a temporary directory and then a lot of functionality that's hung off of that. I use that a ton when I'm doing things that I want to save a file or write a file, but I want that to get cleaned up at the end of the test run. Just fantastically helpful, in my opinion.
Well, when you change mixture to mixture, there was a line under the mixture part in your program.
Yeah, it's because this is called Flake 8, and so Flake 8 is a linter, and I have it integrated with my editor, and so it's helping me see before I run this that I've got an undefined variable there essentially. So that'll go away. That actually didn't have anything to do with the fixture, but it's yeah. So let's go back to fixtures and talk through what we're doing here. So the first fixture that we're going to define here is the app, and so this is how we instantiate the app. This is not the app context. This is just creating the app. So if we go back to the code that I wrote up here, this code is essentially doing what this does. How many times do I need to instantiate the app per test run? One? It's arguable, but a lot of times it's one. If you're doing something where you're testing different ways the app can be configured, which affects its behavior, you may want to instantiate it more than once. But in that case, you would probably just be using the create app itself directly, and you wouldn't be using fixtures for that. So it's very common in what we're doing where the app's going to kind of get set up one way for all of my tests, and what I'm testing is not really the app configuration. I'm testing the app functionality, and so I just need an app. So as a developer, I don't want to think every time about, okay, I'm going to go set up an app. I just want to go set me up an app. And so that's what this fixture is going to do. I could create, if I had another function in here, I could do this. And in that case, app here would be the actual app that was created, the app instance, the Flask app instance that was created right here. This, when it's returning whatever this fixture returns is what's getting assigned to this parameter, to this function when you use the fixture. The reason you don't see me using that is because we're going to get into kind of the nested nature of some of these, the setup of some of these libraries. So that's the first thing I need. Well, the second thing that I need is I need to have access to the database object, but I need that database object to be working in an app context. Because as we saw before, I did things like db.createAll, and it failed because it didn't have an app context. I would do other things like this. Any of these things, if I didn't have an app context, would fail because those Flask SQLalchemy internals would try to figure out what the current app is, and it couldn't figure it out because there's nothing on the stack. So I have, do I use that? I think I do in test views. So we'll talk about why this is here in a little bit, but I just want to show the use of this fixture. So I don't actually use DB. I don't use this DB parameter anywhere in this setup function, in the setup method. But the reason it's there is because I need the stuff that this fixture is doing. I need to be active when I call that code. Otherwise, it's going to give me an error. So let me just show you that. So right now, all of my tests pass. I think I fixed that. Okay, and if I come in here, even though I'm not using DB here, if I run this, I'm going to see that same error I saw before, which is no application found. So that fixture is setting up setting up the app context for me. Okay, so that's the second fixture.
Question.
Sure.
How do you close your class at the end of it?
Yeah, so the app context, you mean?
No. Okay, let's go further up. It's right there. Your conf test pipeline. How do you close it? Oh, that's the name of the file.
Yeah, that's the name of the file.
Okay, what about the add pi test? It's just after the return command.
No, so Python's a white space language, so you don't need like a bracket or a...
The indentation closes it. So when I get over here to the left, that closes that function. It's very different from like JavaScript or C, where you've got to have curly braces to bracket your scope or your blocks. Any other questions? Okay, so the second, so we talked about DB and what it does. Notice here that fixtures can use other fixtures. So this is one of the really nice things about fixtures is you can begin to kind of compose them. So I used the app fixture because I needed to push the app context. I also need to, didn't mention this earlier, the scope is really important. This is what's going to ensure that I only run this fixture once. So I can call that fixture many times, but by setting scope to session, it's only going to run that function once per test run, not like individual test method run, but the whole complete test run. It's only going to run it once, and then it's going to cache that object and keep giving it back to me without the expense of spinning up that app every time. The DB, I don't want to be scoped to the session or anything else. There's other scopes like class or module, but I don't want it to do that because I actually want a new app context brought up. And then this is also really important in the SQLchemy world. Your session is kind of like is kind of like a transaction. It's really not a transaction. It has a transaction involved in it, but it also caches objects. And so it's really important that you don't let your session from one test bleed over into another test. And we're making sure that we prevent that by removing the session here at the end of the use of this fixture. One of the other things that I like to do with my database models is I really don't like creating test data. So when I create something, if we look at these tests, when I create the post, for a lot of tests, for a lot of things that you're going to do, you might care about one or two fields in an object that might have tens, maybe even 100. And so a lot of times I just want all of those other fields to be filled with random data, and I only want to set the data that I care about that I'm actually going to test. There's two general ways to set up data for tests. Anybody tell me what they both are? What the two different ones are? Well, tables are where you put the data in. Migrate is how you get changes in your database upstream. Anybody else? This is good. Like, I'm not trying. Yeah, keep going. Factories. And anybody know the other one? It's an F word. Fixtures. So factories and fixtures. I think a lot of people used fixtures, and fixture was kind of the first thing that you did, and it was basically kind of like set up all of the data that you need and import it, import it. And over time, what happens is those fixtures end up being really hard to maintain. So imagine, a larger application, that maybe has tens of tables, and you have tens or hundreds of fields on each one of those tables, and you have, probably 1,000 different fixture files with all kinds of different data scenarios that you've come up with that your tests depend on. And now one of those tables that's really at the core of your whole graph adds three columns. Do you know how many fixtures you're going to have to go through and add data to? It's going to be a ton. So I actually don't prefer fixtures. I prefer factories that automatically just generate random data as needed and sets those entities up. So that's actually what we're doing here. There's a library called Mixer. And Mixture is designed to work with SQAlchemy and other ORMs to essentially, it inspects your object and it knows how to fill its fields with random data. So, but that library needs a little bit of setup, and so I've done that here. This is the Mixture extension. I've done some imports here at the top. You can read about Mixture. You can read about its documentation if you want to, but it needs a little bit of setup here. And so note, I had to use the DB fixture because the setup actually requires the database session to be present. So it does some stuff that if I didn't have this here, we would get that, I don't know which app is active again. So I pull that fixture in, and then I create the, I'm sorry, I'm one down. I need the app. So I need the app, and I only need to do this once. The Mixture extension itself only needs to be initialized one time, but each test that needs to use it needs the Mixture extension and it needs the database. So I can get both of those things active with one fixture. Again, just trying to show the composability of these things, which means that for a test that wants to use the database and wants to create some random data, I don't need to import like 3 different fixtures. I don't need to import app and then import DB and then import Mixer. I just need to do Mixer because I've set that fixture up to do the other setup for me. So again, once you learn how this stuff works, it actually ends up being really nice to get a lot of this set up, and it makes the user experience of using these fixtures really nice when I only need 1 instead of 3 in every method that I make here.
Question: if you wanted to do a different method, like say you want the Postgres server to rebuild a database.
Okay.
Execute a sort of procedure to do that. How would you do it if you're going to pull out? You want to have a set database. You want to have something that you want to have the server, SQL server do it for you.
Yeah. So, well,
How would you follow the sort of procedure in your test?
That would get into, so Psycop G2, if you go to the requirements, this is the library that I use for interacting with PostgreSQL. And if you read the docs, this is a specific binary version. This is really the name of it, Psycop G2. If you look up that and you Google that and stored procedures, it would show you how to use that library to call a stored procedure. So you'd obviously need to have that stored procedure present, which could be a matter of just executing the SQL that creates the stored procedure. But executing it would be, you just need to look at the docs to see how to do that.
You want to have your database secure, but you want to pull it from someplace that, pull it in someplace that's not secure. You have a secure database, you don't want anybody tampering with it, but you want to pull it out. You want to pull a copy of it out to work with.
I may not be tracking you, but I can get with you afterwards if you got another question. Okay. Okay, so anybody have questions about fixtures or why we need so many to get to this place?
They're just functions, right?
They're basically functions without parameters. Yeah. Although you can use other fixtures in them, but you can't, I can't call Mixer with something, which is one of the limitations. So we actually use, at level 12, we actually attach every object, every entity, and every model has a method on it called testing create. And so that's how we create our random data. And then we have some utilities that automatically kind of populate the random data. It's not Mixer, but that whole setup requires a whole lot of other stuff. And so I just didn't want to try to bring that all in and keep the concepts relatively simple. Okay, so let's think about what we want to do from a testing perspective here. So if we're going to run a lot of database tests, in the same way that when the system starts up, we want to have new tables created, often when our tests start up, we want to have fresh data. So we don't want data that's existing in the database. Remember that the database is one giant state store. So we don't want this data that's in the database to be confusing or breaking our tests. So there's all kinds of different ways that developers have talked about how do we deal with this problem. This is the way that I've solved it, the general way that I approach this. I believe that the tests that are running are responsible for clearing the state before they run, as opposed to tests needing to clean up after themselves. Here's why. first of all, a test that's going to clean up after itself is going to basically have to clean up everything. But it could be the case that it actually could leave a bunch of data around and it wouldn't hurt anything for another 150 tests. And so I just feel like it's easier to reason about what the current test is about to do and to know, okay, these are the tables I have to clear before I start that test, than it is to try to guess at what tables might have to be cleared, which usually ends up just being delete all the tables, or, clear all the tables because I just don't want to mess with it, which might be a good strategy. You might actually do that and just have all of the tables cleared after every test. But for whatever reason, beforehand has seemed to work a lot better for me. And it results in, like, if I know I'm only dealing with one table, I only have to clear that table, and I don't have a whole lot of wear and tear on the rest of the database. So that's why I do it that way, and I demonstrate that here in a different file. So, yeah, I had it open. Okay, so that's what test views is doing. So this is another type of fixture. The fact that this fixture is defined on a class method means that this fixture will only run when the methods in this class are running. So this won't pollute into any other class space. It'll only apply to this class. And the auto use equals true is what's required to essentially tell PyTest, hey, I want you to run this fixture regardless of whether these test methods actually ask for setup. I want you to run it anyway. So it's a way to prefix every test with some current code. As I said before, I have to have the DB fixture, otherwise this won't run. You'll see that I'm only clearing the post here. That works because I'm not concerned about comments, but it also works because in my entities I set up a foreign key and on-delete cascade relationship. So even though test views is not working with comments at all, there's actually comments when this test runs. If you run the whole test suite, test model runs before test views. Test model creates comments. If you didn't have the on-delete cascade and you tried to delete all your posts, it would throw an error at you because there's still comments in the table that it's trying to delete. So I have a tendency to use foreign keys and delete cascades for everything because it makes reasoning about what needs to be removed just a lot easier. So test model, the blender, mix.blend, end.post. When this library is properly set up, this actually results in a post entry being created in the post table. So I get a record inserted into that table. My test is asserting that there's only one of those. I can run with -s so that you can see. Here's the -s says actually show me output. Normally when you run PyTest, you won't see any of the output. It kind of keeps it out of the display. This is that first post that I've created. You'll see that the title there, part of that is the title, and you'll see it's just random words. If I run it again, we'll get different words, showing you that that mixture is actually filling in the data. And test comment is very similar. The only reason I did it is to show you that right here we print comment and then we print comment.post. Mixture is being very helpful in recognizing that there's a relationship on from comment up to post, and that a comment can't exist without a post, and so it goes ahead and creates the post as well, not just the comment. But you'll see in the test, I didn't have to do any of that. I just had to tell it, give me a comment. And it did the reasoning to figure out what else would need to be created to give a referential integrity for the comment. Query.count, this is all, once you get to the query section, this is really now all SQLalchemy. Flask SQLalchemy has done its job of setup. .query is a query object, an SQLalchemy query object. And you just read more docs on what that looks like and what it can do for you to figure out how to use it. Any questions about testing the model? Okay, so a brief look at the views. So these would be where you send your web requests to. Just to show you what this looks like, do flog serve, run, open that. It's not found because I don't have an actual home route. So there's hello DerbyPy. If I did post, it's not going to work because, oh, I guess I do have data in the database. Great. I have the test. I have the test one in there. Hey, that's actually something that I didn't do. I should really be using a different database for my tests. Make sure if you use this for something that you set up change the URL for your testing to use a different database for testing. So these are my two views. Again, this is all Flask. The only thing that's a little bit more advanced is the use of a blueprint here. As I said, you get import circular import issues here if you don't use a blueprint. And so I'm using a blueprint to avoid that. And you can read about Flask blueprints. They got a lot of good docs on those. So here's one that's just returning text. And here's one that's fetching all of the posts and just running through and creating a list out of the titles and then putting a return character between them. And this is the test for that. Test hello. Oh, let me show you the client. So the Flask gives you the ability to create a client, or what essentially is kind of like a browser, a way to send requests to the application like a browser would. And so you can post data, you can get data, you can use different verbs if you want to, and it's got some nice. There's some nice functionality built into it that you can look at in terms of getting access to some of the global objects so you can kind of inspect what the code is doing. So this is really simple. Again, we're using a nested fixture to get the app. I call app.testClient and return it. So that return value is what this object right here is. I'm going to set up my database to have one post in it with the title of foobar. I'm going to call client.get, which is just like browsing to it with your browser, and I'm going to make sure that the data that comes back is just foobar. And if I had created two posts, then I'd get foobar, and it would have a return character in it, and then it would have the title of the second post. Any questions on that? Okay, any questions on anything? Because I think that's about all I got. Okay. Oh yeah, absolutely. Yep. Yeah. In fact, Flask gives you a nice, it gives you some nice tooling for. There's like Flask.jsonify, and so you can actually return something like. Let's see. Because I'm not using it. Okay, so let's do. I'm sure there's a better way to do this, but this is just to show you that it works. And so now I get post titles. So instead, I'm going to return. I did for the URL. Yep. Let's see if that works. If somebody sees I did something wrong, let me know. Ad hoc coding's never safe. There you go. Yeah, sorry, I guess you can't see that, but it's there. It's there. Say it again.
I thought you rolled up, right?
Well, it's a single list. It's only a single list item with a string in it. So, yeah, here, let me. It's because, okay, let me show you. It's because Firefox is displaying that data for me pretty formatted. Anything else?
So I have a question, but it's not exactly like this. But it's something that you mentioned.
Okay.
The blueprints. Python allows for importing modules in a way that it they have diamond dependency.
Well, so those are two different things. Diamond dependency has to do with inheritance. Right. Because everything that Python done is at runtime So let me show you the problem. I can demonstrate the problem. The problem is, so if I didn't use blueprints here, what I would have to do is I would have to say from flog.app import. Oh, I can't even do it actually because there's no app instance. Remember, I'm using an app factory.
Okay.
So I can't even get a hold of that app because normally Flask would want you to do something that looks like this. App.route. Well, first of all, when this is imported, there's no app because all this stuff is going to kind of get imported at once at the very beginning before create app even runs. And so,
Is that just for tests, or is that in the actual runtime?
yeah, it's just in the runtime because what's going to happen is, well, first, yeah, I can talk to you about it after we want. It actually it just has to do with the way that Python importing works because it's all at runtime. If you get one module over here that imports from this module, but that module imports from that module, this one will import that one looking for something that may not actually have been executed yet. And so this one will say, oh, that thing's not there. And it is there. It's just not there because that part of the code hasn't run yet.
Is there, is that allowed because there's a usefulness to that somewhere, or is that just something that?
It's a byproduct of Python being just a runtime instead of like a compiled language where you can get all of your references and then kind of reference them. You can get all your objects created and then you can kind of figure out where they all are.
Yeah, I mean, sure. Well, maybe not sure. It possibly would. It could when it finds that sort of interdependency, it could be like error out earlier, or is that what it does?
I mean, it's giving you the error as soon as it can, but it's giving you an error that doesn't make sense unless you understand what you've just done. Because what it's going to say is you tried to import DB, let's say, and DB isn't there. But you're like, it is. What do you mean it's not there? You're looking at your code and you're like, it's right there. Like, why is it not? Well, it's not because if I go flog.views import blueprint, oh, invalid syntax. What did I do? I don't know. No, I don't know why I'm having problems here, but
Not allowed to import from.
yeah, I guess so. Yeah, it's just the way. I mean, Python, everything at runtime, just the way it works. I'm sorry, I'm not doing a better job at explaining it. I'm just insisting over and over again that that's the way it is, without any better explanation. And honestly, I don't know if there is a better. Like maybe Alex can do it. Can you do a better explanation?
I mean, every Python application has a single point of entry, and then it's basically the stack machine is value. And so what was going to happen later is when you had from class.views import whatever, before Python is evaluating each line as you go. And so the minute it hit from class.views whatever, it's going to go look for that. Well, when you import, the first reference to a module actually evaluates the entire module. So a module in Python is about 5. That's why if you have globals, even if you don't import that global, if you import that module, that global is going to evaluate using interesting behaviors from that. Well, when you do from views import public, if log views has a reference to DB. DB doesn't exist yet.
Yeah, you'll actually.
Is going to evaluate. But DB has never come into scope.
And that's what the blueprint stuff gets you.
Oh, I guess that's the right error. Cannot import name DB. So this is happening in entities. So this is actually, you'll notice my import was down here because of this issue. I had to put it inside of that function so it wasn't executing right away. So what happens here, this line gets executed, and as this line gets executed, this file pauses. So, or the execution of this file pauses. So db equals SQLalchemy has not been run yet. So in this module's namespace, there is no DB. Okay, so then we go to views. From views does from flog.model.entities import post. So now I got to go to the entities file. That runs. And at the very top of entities, I do from flog.app import DB. Well, again, this executes and it tries to import from that namespace. Exactly. But this one, it's still waiting to finish that execution loop. There is no DB there. So I could actually solve this. I could solve this by doing this. Yeah, but now my linter's mad.
But you solved it.
Oh. All right, now what did I do? Cannot import name view from flog. Cannot import name. There we go. Again, the danger of live coding.
So, you're doing sort of that circular importing dependency-ness, but you're getting around it because you're instantiating stuff before you're doing your importing. Is that kind of style, is that recommended? Is it useful?
Like this?
Yeah, like this.
I mean, you can do this when you have to. I mean, sometimes in Python you do things that don't look the best because you have to. I prefer to do it like I did.
Where you put it in the...
Where I put it in. So the downfall of doing it here is every time create app runs, it's gonna do that. It's gonna redo that import. So it's like just a little bit slower, which may not actually matter much, but it could if you were in a situation where like you were creating a library and you were instantiating just a ton of apps all the time. It may matter just a little bit. I'd profile it before I'd care a whole lot, but yeah. Well, there you go. And you're doing it in Python? Okay. I know. Lots of it. Lots of Python. So does Microsoft these days. Like, Python's eating the world. Anybody else?
Along those lines, is there like a bundler that I do more JavaScript stuff.
Okay. Mm-hmm. Mm-hmm.
JavaScript uses to kind of read all the files and figure out the whole tree, right? And then kind of shake it out and say, okay, these things are needed, and then kind of give you a nice neat bundle. And then there's like splitting that you can do to make it more efficient. I'm just interested if you know if there's any Python projects that kind of do that.
I don't think so. You get Python projects that'll package your Python. So one of the difficulties about Python is there's no good way to kind of package up an entire app. Like by default, there's no good way to like take all of your scripts and kind of an active virtual environment and the Python interpreter and put it all together. Like there's no way to do that with just standard Python. I don't think, right? It's all extra libraries. So there are extra libraries that do some of that where they'll package it all up into an executable for certain platforms. But I've never heard of something that does that and also kind of shakes out code. And I think probably the reason for that is in that bundling process, like the Python runtime and the standard libraries are going to be huge. And that's going to account for most of it. And I guess maybe you're saying, well, maybe you could start to shake out some of the standard libraries that aren't used. I still think most of that Python code probably pales in comparison in size to just having to package the Python runtime itself. Anybody else? Yeah, I know. Well, actually, I got a joke for you. Where's the developer go to get a drink? Foo bar. Foo bar. All right. Thanks, everybody. Have a good night. I'll hang around in case you got other questions.